Good morning, students. So today we are here to start with the lecture number 9 of kinetic theory of gases. So in this class we will be discussing numerical problems. So here I am having the first problem for you. So problem is, so first question, you can write question number 1. Calculate the mean free path of nitrogen. Calculate the mean free path of nitrogen. Calculate the mean free path of nitrogen molecule at 27 degree Celsius, and when pressure is 1 atmospheric pressure 1 atm, and given that D is equal to, D means diameter of nitrogen molecule. Okay, this value is given to you as 1.5 angstrom. Angstrom means 10 to the power of minus 10 meters. Okay, 1.5 angstrom as the diameter value given, and K value given as 1.38 into 10 to the power of minus 23 joule per Kelvin. And second one we are having in this problem only, this is first one part. Okay, calculation of mean free path, and one more part, let us call it as 1, and second part they had given that they are asking about if average speed of the molecule is 675 meter per second. So if average speed is equal to how much they are telling us, 675 meters per second. Okay, so find the time taken by the molecule between two successive collisions. Okay, they are asking about time between two successive collisions. Clear? So they are asking about what is the time taken for that molecule between two successive collisions, and if they are calculating time in some of the question, they may ask frequency also, which is nothing but what, 1 divided by time. Okay, so you can note down the question. So how we can proceed with this? Okay, we should have to go for the solution of this part now. Okay, shall I erase this question part? Okay, listen. Have you noted down the question? Pause the video and note down the question. I am going for the solution part now. Okay. All right, listen. Solution part. So temperature value they are telling that is 27 degrees Celsius. So T is equal to 27 degrees Celsius. But we want this T in terms of what? Kelvin. So what I should have to do? Plus 273, which will turn out to be how much? 300 Kelvin. Clear? And next about pressure, they are telling that pressure is 1 atm. Okay. In fluid mechanics already we had discussed 1 atm means what is the value for 1 atmospheric pressure in SI unit, I mean in Pascal or Newton per meter square. What is the value for this? This value will turn out to be 1.01 into 10 to the power of how much? 1.01 into 10 to the power of plus 5 Newton per meter square. Okay, otherwise we can write 1.013 also. Okay, 1.01 into 10 to the power of 5 Pascal or Newton per meter square. Okay. Now next value we are having about a diameter value given to you, that is nothing but 1.5 angstrom. What is the meaning of angstrom? What I had told you earlier. Angstrom means how much? Angstrom stands for 10 to the power of minus 10. So that's why this value I can write it as 1.5 into 10 to the power of minus 10. Diameter, angstrom means 10 to the power of minus 10 meter. Clear? So D value also given, D value also we had noted down. Okay, K value given to you 1.38 into 10 to the power of minus 23 joule per Kelvin, or Jk power minus 1. Okay. This is nothing but our given part. Okay. Clear. Next. This is all about, in first case, what all the things they had given, all we had noted down. Okay. In second case, they had given about speed. Let us talk after this solution. Okay. About that part, first we'll complete solution for this. Later we can go through that. Okay. Okay. Now, what is our formula? Mean free path. What is the formula for mean free path? What we had discussed earlier. So in our previous class we had derived equation for mean free path. Correct, no? So lambda is equal to kt whole divided by root 2 pi d square p. Clear? Lambda is equal to kt divided by root 2 pi d square p. So k value here you are having, t value here you are having, root 2 value you calculate. Okay, approximately 1.4, pi value is 3.14, d value is 1.5 into 10 to the power of minus 10, but a d square means this complete quantity square, 1.5 into 10 to the power of minus 10 square. If you square this term means 10 to the power of minus 10 square means it will turn out to be 10 to the power of minus 20, remember. Next p value here you are having 1.01 into 10 to the power of 5. So shall we go for the proceed? Shall we proceed for this now? Okay, listen. We should have to substitute the values now. Okay, shall I erase this part or here shall I write? This feels a bit uncomfortable over here. K value is 1.38 into 10 to the power of minus 23 into t value is 300 whole divided by root 2. Okay. Pi value is 3.14. D value is 1.5 into 10 to the power of minus 10. This is whole square. P value is here we are having 1.01 into 10 to the power of 5. 1.01 into 10 to the power of 5. Clear? So 1.38 into 10 to the power of minus 23 into 300 divided by root 2. Root 2 value will be almost 1.41. Okay, 1.41. Okay, 1.41. Pi value 3.14. D value 1.5 into 10 to the power of minus 10 whole square. Next into 1.01 into 10 to the power of plus 5. So if you calculate this out means how much you are going to get approximately near value. Nearby value you can calculate by treating this as 1.5, this as 3, okay, this as 1, this as 1.4, okay, approximately. Check out how much you are going to get. Shall I check here? Okay, so approximate lambda value you are going to get, that is nothing but mean free path value you are going to get 4.1 into 10 to the power of minus 7 meters. Okay, 4.1 into 10 to the power of minus 7 meters. Cross check it once again. Okay, so we go to next question. So what all the values we are having? 1.38 into 300 divided by 1.41, correct? No, divided by 3.14 divided by 1.5 divided by 1.5, okay, divided by 1.01. So this will turn out to be 41 somewhere. Okay, so by leaving this powers I am getting 41. Next, if we talk about powers, means minus 23 is in numerator and this plus 5 will come to numerator and it will become minus 5, correct? No? Okay, next this minus 20 will come to numerator and it will become plus 20, so we are going to get here 10 to the power of minus 8. So shift the decimal point. So decimal is shifting left side. 4.1 means 10 to the power of minus 7. Correct. Clear? Okay. Now next. Next part in this question we should have to proceed now. Okay. Shall I erase this part? So remember this value lambda we are getting 4.1 into 10 to the power of minus 7 for our next part. What is our next part? What they are asking? Time interval between two successive collisions. Okay, t value they are asking. T is nothing but what? From speed distance formula, t is nothing but what? Distance divided by speed. Distance is nothing but this one, speed value they had given in our question. Alright, listen. So in B part they are asking about what? A time interval. So t is equal to what I can write? T is nothing but what? A distance divided by speed. Distance value mean free path only 4.1 into 10 to the power of minus 7 whole divided by speed value. Once again. S value in our question only they had given. S value how much they had given in our question? 675. Correct, no? So if you calculate this out, means how much you are going to get, just cross check. So 4.1 divided by 675. So approximately you should have to get about how much? Yes, anyone got? 0.0060. Correct? 0.0060 into 10 to the power of minus 7 seconds. Correct? Shall we go to next question? Okay. Next question. Calculate the mass of 6.5 into 10 to the power of 24 atoms. 6.5 into 10 to the power of 24 atoms of gold. Okay, these many atoms of gold. Okay. So, and they had also given that the molar mass of gold is 197 gram per mole. The molar mass of gold is 197 gram per mole. Yes, we should have to do solution of this now. First of all, they had given molar mass. That means in 1 mole, how many grams will fit? Okay, in 1 mole, dash grams. This is nothing but 197 value they had already given to us. Okay, so now that means molar mass treated as capital M. So capital M value given 197 gram per mole. Clear? Okay, next. We should have to remember Avogadro's number, that constant value. In a value we will be having, no? That value we should have to remember. That value is how much? 6.02 into 10 to the power of 23. Okay. So this is nothing but what? Avogadro's number. So these many atoms or molecules per mole it is. Okay, 6.02 into 10 to the power of 23. So now mass of 6.5 into 10 to the power of 24. Mass of 6.5 into 10 to the power of 24 atoms of gold it is. Correct? So small m, how we can calculate? Come on. So 6.5 into 10 to the power of 24 divided by what? 6.02 into 10 to the power of 23. Okay. This value where we are having 6.5 into 10 to the power of 24 divided by Avogadro number 6.02 into 10 to the power of 23. 6.02 into 10 to the power of 23. Of gold, molar mass how much they had given? 197. So just cross check how much you are going to get this one. 6.5 into 10 to the power of 24 into 197 divided by 6.02 into 10 to the power of, this is 23. Okay. Yes. Anyone got? 212.7. Into, here 24, denominator 23 means, into 10. Or how we can write it? 212, these many grams, or we can write 212 into 10 to the power of 3 grams, or 212 kg. Clear? Okay. Clear? Shall we go to next part? Shall I erase this part? Copied? Okay. Listen. Next question. Find the number of one second. Find the number of moles and the number of molecules in molecules in 2 liter of an ideal gas. 2 liter of an ideal gas at a pressure of 50 Pascal and temperature of 300 Kelvin, and T is equal to 300 Kelvin. So how to proceed with this question? First of all, write down what all the data they had given. So 1 liter is nothing but 10 to the power of minus 3 meter cube in conversion of volume. Remember, 1 liter is nothing but 1 into 10 to the power of minus 3 meter cube. Okay. Now, first of all, this is nothing but question part. Here you write down solution part, and first of all write down what all the quantities they had given in our question. Okay. Yes, what all the things they had given. V is equal to volume 2 liters. Correct, no? The number of molecules in 2 liter. That means volume value they had given. This value is nothing but 2 liters, or 2 into 10 to the power of minus 3 meter cube. Okay. Next. Again what they are telling. Pressure is 50 Pascal. Okay. P value given 50 Pascal. P value given 300 Kelvin. And again, you should have to remember about R and Avogadro number values. R is nothing but universal gas constant. What is R? Come on. Have you remembered? R value is nothing but 8.31. Okay. Joule per mole per Kelvin. Shall I write that? Joule per mole per Kelvin. R value. Next, Avogadro number. Just now we had written in our previous problem. Avogadro number 6.02 into 10 to the power of 23. Okay, 6.02 into 10 to the power of 23 per mole. Okay. Yes, which formula we can apply now here? What they are asking? Number of moles. N value they are asking. Clear? Can you able to see that clearly? N value they are asking in our question here. Okay, N value they are asking. Now, by which formula we can calculate N value? Can you just think about this one? So simply we can apply ideal gas equation, which is nothing but what a PV is equal to nRT, and calculate with respect to that. Okay, so N value will be equal to what according to that formula? PV is equal to nRT, or N is equal to PV by RT. PV by RT. Substitute the values. P value is 50. V value here 2 into 10 to the power of minus 3 whole divided by R value 8.31. Next T value 300. Clear? So if you calculate means how much you are going to get, just check it. 50 into 2 is nothing but what, 100. 100 into 10 to the power of minus 3 divided by 300. 100 by 300 means value will be 1 by 3. 1 by 3 divided by 8.31 into 10 to the power of minus 3. Okay. Into 2 is nothing but what, 100. 100 by 300 is nothing but 1 by 3. Okay. So how much you are going to get? 3 into 8.31 is in denominator. 3 and 8.31. So complete factor if you calculate means you are going to get how much? 0.040, correct? 0.040 into 10 to the power of minus 3, or you can tell it as 4 into 10 to the power of minus 5. So N we had calculated these many moles, correct? So if you want to calculate number of molecules means, if they are asking here, find the number of moles and number of molecules. So these many moles we are having, okay. So total number of molecules will be how much? How many moles into, in 1 mole, how many molecules will be there? Clear? So shall I write it over here? Total number of molecules. We are having totally 4 into 10 to the power of minus 5 moles, and in 1 mole Avogadro number of molecules will be there. That's why 4 into 10 to the power of minus 5 into 6.02 into 10 to the power 6.02 into 10 to the power of plus 23. Just calculate this factor, how much you are going to check. 4 into 6.02. So somewhere near to you are going to get 24.08 into 23 minus 5 means 18. 10 to the power of 18. Clear? Or you can write it as 2.4 into 10 to the power of 19 molecules. Otherwise 24.08 into 10 to the power of 18 molecules. Clear? These many molecules. I hope you are understanding the numericals. Please practice the numericals correctly, thoroughly. Okay. In this question, actually what they are asking about how many number of moles and how many number of molecules in this much volume. Okay, ideal gas they are telling, given gas is ideal gas, so that you can apply ideal gas equation, PV is equal to nRT, and for that pressure value, temperature value given to you. This conversion they won't give you, you have to remember this one. Okay, this is nothing but, we know that 1 liter is equal to 10 to the power of minus 3 meter cube, remember this value. And R value, Na value, standard constants, you should have to remember these values also. Clear? So please don't waste your time, keep studying. Again we will meet in our next class. Thank you.